For a saturated sand deposit, the void ratio and specific gravity of solids are 0.7 and 2.67 respectively. The critical upward hydraulic gradient for the deposit would be. So for a saturated sand deposit, void ratio E and specific gravity G. So this is E, this is G are given. So critical upward hydraulic gradient. So what is hydraulic gradient? That is denoted generally by I. So head divided by the length. So pressure drop for unit length, or the head per unit length is called hydraulic gradient. Okay, so sorry. Okay, so pressure drop per unit length is called hydraulic gradient. Now here generally why critical upward it is said, it is actually, you can see it is in critical hydraulic gradient generally happens in upward flow only. So in upward seepage there can be quicksand phenomena due to the zero effective stress condition which can happen. Okay, now when does that happen? Critical hydraulic gradient, when does that happen in the seepage, upward seepage? When effective stress become zero, that is the critical condition. Okay, so now see, let us upward condition, let us say, let us take this. Okay, okay, so I am taking, this is soil, let us take, this is soil and there is water, and water is also here, and there is some outlet and there is some inlet continuous. So the height, so this is the water which is coming from which is flowing from here to here because there is some head difference. So if there is no head difference, there will not be any flow. As there is some head difference, there will be flow in this direction. Okay, so now from here there will be upward seepage, right? So when it is, there is upward seepage, so let us say this is head difference HS, and now if you calculate effective stress at this point, at the starting point of the soil when it is moving from down to up, so effective stress at this point will become, so let us say this height is capital H. Okay, now this is fully saturated, so saturated, and if submerged unit weight you can say is gamma dash. So effective stress at this point, let us say P sigma, it will be gamma dash into H minus gamma into gamma W into HS. So effective stress at any point will decrease by the seepage head pressure. That at that point, what is the seepage head causing flow multiplied by the unit weight of the water, that much amount will be deducted from the effective stress only due to the soil. So this is effective stress due to the soil, and this is the seepage pressure. You should deduct seepage pressure at any point from the effective stress at that point. That will become the final effective stress, net effective stress existing in that point. So this can become zero when HS will increase. So this will not increase because H is constant. Okay, gamma dash is also constant, but here H gamma W is also constant when you are increasing this height. Okay, this container height, so HS will also increase. Because of that, at one point this total term can become 0. When this term can become 0, effective stress will be, net effective stress at point will be 0. So that is critical condition. So let us sigma dash equal to gamma h minus gamma w hs. If it becomes 0, then that is critical condition. So critical condition, right? Now what I do, hs by h is gamma dash by gamma w. So gamma dash can be written as gamma sat minus gamma w divided by gamma w. So here gamma sat by gamma w minus 1. So see, head causing flow divided by the length of the length of water, the path of traveling of water through this much length due to this much head. So the head causing flow divided by the length of traveling of water due to that head is called hydraulic gradient, right? That is I. So now I, it is as we made it 0, so this is critical hydraulic gradient, right? So now gamma sat divided by gamma w minus 1. Now here we know gamma sat is nothing but g plus e 1 plus e, whereas gamma w is gamma w. So now gamma sat g plus e gamma w by 1 plus e, this is gamma sat divided by gamma w minus 1. So gamma w I'll g plus e by 1 plus e minus 1, right? Now g plus e by 1 plus e minus 1, g plus e minus 1 minus e by 1 plus e, so g minus 1 by 1 plus e. Therefore IC equal to g minus 1 by 1 plus e, right? So now here we need to find out IC for the deposit would be. So what is formula which we derived? G minus 1 by 1 plus e. So IC is g minus 1 by 1 plus e. What is g here? 2.67 minus 1 divided 1 plus e. E is 0.7. 1.67 divided by 1.7 equal to 0.98. So answer is B. Thank you.